Hi, this is Ms. Park, and this video is a lesson on writing the equation of a circle with the center at the origin. Just remind you that the origin is the point 0, 0. Okay, so we'll be talking about circles whose center is 0, 0. So let me make a circle over here. Doesn't have to be perfect. Okay, and the center is 0, 0. Now, the definition of a circle is the set of points that are all the same distance from the center. So pretending that I drew this circle perfectly, this is the distance from from the center of the circle to any point xy. Okay, and because you recognize this little line that comes from the circle, that comes from the center and goes to the outside of the circle, we call that the radius. Okay, now if we look a little closer at what we have here, I can draw a right angled triangle that goes down here to the x-axis, and then I can label the side lengths of the triangle. I have the hypotenuse as r, or radius, and then what is the length that goes along the bottom here, the bottom leg? So that length is x. Okay, so to get to the point xy, I've got to go from the center x units to the right. Then I've got to go y units up. So what ends up happening is in my right angle triangle, I can use the Pythagorean theorem to write a relationship that looks like this. Well, a squared plus b squared equals c squared, so x squared plus y squared equals r squared, where r is the radius of the circle. And that's called the equation of a line. It's called the equation of a circle with center 0, 0. So how do we use this? Okay, so for example, let's do example 1. Okay, find the radius of the circle, and let's give it an equation. Let's call it x squared plus y squared equals 25. Okay, now we know if it looks like x squared plus y squared like this, then the center is 0, 0. We know that. And this 25 is r squared, the radius squared. So therefore, the radius is equal to 5. Okay, so the radius of the circle is equal to 5. And we can sketch this circle. In fact, we can sketch any circle that's got the center 0, 0 and find 4 quick points. Because if the radius here is 5, then I know this is the point 5, 0. And I know that this is the point negative 5, 0. And I know that up here is the point 0, 5, and down here is the point 0, negative 5. Okay, and so that's how we would use it. Let's do another example for using the equation. So example 2 would be find the equation of a circle with center 0, 0, or center at the origin, same thing, and passing through the point, and then we can pick any numbers here. Let's go negative 1, 7. Okay, so we want to find the equation. So I'm going to start by writing the equation of a circle. X squared plus y squared equals r squared. Problem is we don't know the r squared. So because we know that this point, negative 1, 7, lies on the circle because it passes through it, we can sub it in because that point will make the equation true. Right? If a point sits on a graph, it makes the equation of that graph true. So I can sub this in and I get negative 1 squared plus 7 squared equals r squared. And so 1 plus 49 equals r squared. So 50 is r squared. So the equation is x squared plus y squared equals 50, right? That's r squared. If somebody asked us for the radius of this, that would be the square root of 50, whatever that happens to be. Okay? If you get a whole number when you square root it, then write the whole number. But if you don't, then just leave it as a radical, as a square root, because that's going to be the exact value. Okay, and then let's do one more example. Example 3 is the point, and we'll just pick a number 2, 5, inside, outside, or on the circle with the equation, and let's just make up something, x squared plus y squared equals 10. Okay, so is this point inside, outside, or on the circle? So if I have a point that's on a circle like this, then for that point, x squared plus y squared, so this is the point xy, x squared plus y squared would equal the r squared, right? Because it's on the circle. But if I have a point that's outside the circle, so let's say out here somewhere, the distance from that point to the middle, to the center, is larger than the radius. And if I have the point inside the circle, then the distance from the center to that point is smaller than the radius. So really what I want to do is I know that the radius of this circle is the square root of 10. I want to know is the distance from my point to the origin, is that longer than the square root of 10, or is that shorter than the square root of 10, or is it equal to the square root of 10? Okay, so that's going to tell me if it's inside, outside, or on the circle. So what we can do is we can take the equation of the circle, and I can substitute the point into the left side and see what happens, how that compares to the right side. Okay, so the left side is this, and the right side is this, and I know that my right side was 10. Okay, and so now let's sub the point in. So that's going to be 2 squared plus 5 squared, which is 4 plus 25, which is 29. Okay, and so x squared plus y squared is clearly much bigger than r squared. So therefore, the point lies outside the circle. Okay, it's saying that its radius is larger, the distance from the center to that point is larger than the radius of the circle. Okay, and there you have your examples. Thanks for watching.